Hey guys, welcome back to another video. This is on using random samples to describe populations. This is unit 8.2, so let's write 8.2 up here at the top, 8.2. And our learning intention for this section is to understand variability in samples of a population. So you're going to know that you're successful with this when you can use multiple random samples to make conclusions about a population. And you can use multiple random samples to examine variation and estimates. So this first page is going to give you a lot of information. This is going to help prepare us for this section. So first, I just wanted to give you a little blurb here. So you have used unbiased samples to make conclusions about populations. So different samples often give slightly different conclusions due to the variability in the data. What's variability? Well, let's talk about it. Variability shows how much the data in random samples can vary. Okay, so when we're talking about variability, we're talking about just how those random samples can vary. So high variability means there are large differences in the samples. And low variability means the samples are similar. Okay, so if you have high variability, you're going to have large differences, which isn't always great, right? And low variability means they don't vary very much. They have a decent amount of the same answers, the same content, and so they're going to be similar. So what is a random sample? Because we're talking about how random samples can vary, but what does that mean? So a random sample is a group chosen from a large population where each member has an equal chance to be selected. Some examples of that would be like picking names from a hat or using a random number generator. Okay, so I'm not favoriting anybody. Everybody's name is going to be in there, everybody's number, and I'm just at random drawing people. Okay, so that would be a random sample. Why would we want to use random samples? So the biggest things is to get a fair representation of the whole population and to avoid bias in the results. Because if I feel one way about whatever data I'm trying to get and I choose people that I know are going to answer it the way that I want them to, then I have not given a fair representation of that whole population and I'm being biased. So when I can use random samples, that's going to tell us whether I like it or not if people are on the same page as me. So let's look at the backside. Again, like I said in the last video, statistics is going to give you a lot to read. Okay, that's just kind of the way it is if you want to understand what the sample is, who's the population, what sample are we using, how are we assessing this, how are we getting our data. You know, all of this information is good things to know, but it's going to require some reading. So let's look at this first one. Using multiple random samples. You and a group of friends want to know how many students in your school prefer comedies. There are 1,000 students in your school. Each person in the group randomly surveys 10 students. The table shows the results. So you found action, comedy, drama, mystery. So then you have friend A, B, and C. So 4 of you each assess 10 people. So this first part, it says, use each sample to make an estimate for the number of students in your school who prefer comedies. So in your sample, 3 out of the 10, because let's see, we said we did 10, right? So 3, 6, 8, 10. So I assessed 10 people. 3 out of my 10 people said that they like comedies, or that would be 30%. And so you can make an estimate that 0.3 out of 1,000. So 0.3, that's how we change 30% into a decimal, right? We're going to multiply that by 1,000 because that's how many students are in my school. So I'm going to estimate that 300 students in the school prefer comedies. So then we can make estimates for the other samples. So then we could say, like, this one, friend A, we can assess here, here, and here. So like If friend A had 5 comedies, then we can assess that 0.5 times 1,000 would be 500 students in the school. Friend B and friend C had the same amount. So if we do, that would be 40%. So we do 0.4 times 1,000, which would be 400. So the estimates are that 300, 500, 400, and 400 students prefer comedies. Okay? Those are the different estimates based off of what each of our data told us. So we're going to describe the center and the variation of the estimates. So the estimates have a median of 400. So median is the middle, right? So if I put all of these in the middle, so 500, all of these in a line, 300, 400, 400, 500, go to the what's in the middle, which would be my two 400s. So that would mean that the median is 400 students, and we have a range, which is the largest number subtracted by the smallest number, so 500 minus 300. We have a range of 200 students. Okay, so this is some information that you're going to be using in this lesson. So let's look at this next section, estimating an average of a population. So you want to know the mean number of hours students spend on homework each week. At each of the 5 schools, you randomly survey 10 students. Your results are shown. So here's our results, hours spent on homework. So each student we asked this or answered these. So a lot of them, if I glancing at this data, are saying above 10, right? 10, 10, 10, 11, 11, 12, 11, 10, 10, 12. So there's a fair amount that are saying over that many hours, right? So here's our first question. Use each sample to make an estimate for the mean number of hours students spend on homework each week. Describe the variation of the estimates. So the first sample, if I add all these together, there was 81 hours spent. I asked 10 people, so I'm going to do 81, divide that by 10, and I'm going to get 8.1. My second set, for the other school, there was 84 hours out of 10 students, so that's 8.4. C, that was 74 hours out of 10 students, so divide that, you get 7.4. My D school had 80 hours. I divided that by 10 because that's 10 students, and it came out to 8. And then E school had 83 hours. Divide that by 10, you get 8.3. So the 5 estimates are that students spend 8.1, 8.4, 7.4, 8, and 8.3 hours on homework each week. The estimates have a range of 8.4 to 7.4, or 1 hour, right? So if I took the largest number, 8.4, and subtracted by the smallest number, 7.4, there was a range difference of 1 hour. So the next question says, use all 5 samples to make one estimate for the mean number of hours students spend on homework each week. So the mean of all the sample data is, so I take all of the number, 81, 84, 74, 80, 83. I'm going to add all of those together, which gives me 402. Then I'm going to add all of the students that I sampled in all of the schools, so 10, 20, 30, 40, 50. And so I'm going to take 402 hours, divide that by 50 students, and my mean is 8.04 hours. So you can estimate that the students spend 8.04 hours on homework each week. So that's how I would estimate an average on a population. Okay, so you're going to have to find mean and median in this. We'll talk a little bit more about mean, median, and all of that in the next lesson, so you can get a good refresher. But these are the 2 things that you're going to be focusing on in this lesson.